Here today to talk to you about ductless heating and cooling systems and why they're efficient. I get asked that question a lot when I go into homes. People, first question is, why is a ductless heating and cooling system efficient, and how do they become efficient? So the first reason why are they efficient? Well, here's what happens when we come into your home. We take a look at the home, we zone out the home, and we basically take your whole home and split it up into areas of cooling and heating needs. So we go in, we look, okay, you've got 3 bedrooms. We're going to put in 3 systems that run off of one outdoor unit, okay? A common area, we'll put in another system. Maybe another kitchen, we'll put in another system. So you'd end up with 5 different zones in the home. So how do I gain efficiency from 5 zones? It sounds like you're going to put in a lot of air conditioning into my home. Well, here's what happens, okay? First off, we have those running, we can have any one of those 5 zones running at different temperatures or in the off mode, okay, running off of one outdoor unit outside at that time, okay? So what happens is when those rooms start to get down to the desired temperature, let's say we have one room set at 72, one room set at 74, one room set at 76, and one room is off, okay? First one was, as soon as it sees the outdoor unit sees that one room is off at that point in time, it says, hey, don't run at full speed. Don't let the compressor run up to full speed. Only run at 75%. Well, when you run something at 75% of the speed that it needs to run at, because I only have 3 indoor units running inside, well, I'm only using 75% of the energy that that unit could absorb at that point in time. Okay, so there's one way of saving energy. The next way is when these units start to get within the temperature range of what they're set for, so the 72, 74, and 76, when the 76-degree unit gets down to 77, 78, it says, whoa, wait a minute, the room's getting cold. Let me start to slow down even more outside and just give me the cooling that I need for that particular temperature. Vice versa, same thing on the 72 and 74-degree rooms. When those rooms start to get within a certain temperature range, within 2 to 3 degrees of the set point, the outdoor unit starts to slow down. So with 3 indoor units running at those desired temperatures, your compressor speed could be running at about 20% of the speed that it could run at. So you're running at 80% less the speed of what that could run at, where your desired amperage of your compressor might be 20 amps at full load amps to run at 20%. You might be running at 2 or 3 amps, just letting those rooms cool off. So that's how we gain the efficiency. Our compressors don't turn on and off on the outdoor unit. They speed up and slow down. What do I mean by that? Have you ever seen, we have 2 different ways of the way we drive. Let me explain this to you. We do city driving and we do highway driving. Your typical air conditioning system, for a central air conditioning system that we've seen in homes for years, is basically a city driving air conditioning system. It turns on when it needs cooling, and then when it hits the desired set point of the one thermostat in the home, it shuts off. As the temperature rises 1 or 2 degrees, the system comes back on. So it's doing a lot of starting and stopping like you would drive on in the city. The Mitsubishi system, which is an inverter-driven compressor, basically drives like cruise control. It does a lot of highway driving, okay? It starts out by starting at a real slow speed. I always tell people, envision you're trying to get onto the freeway and you're putting your accelerator down to the floor, you're speeding up because all the rooms are at a very high temperature, and as we get the rooms down to temperature, we pretty much go into the deaccelerated mode and go into cruise control at a nice fine line. We run a nice fine line of temperature and we run on cruise control, basically taking the compressor and backing off the accelerator, backing off the speed, using less electricity to run that system to gain the efficiency.